Ferrari has just dropped a shocking secret from Abu Dhabi 2025, testing a radical 2026 part that could redefine the championship before the season even starts. The mule car featured a revolutionary double pushrod suspension and cutting-edge active aerodynamics, signaling Ferrari's intent to leapfrog the competition. The twist: Charles Leclerc and Lewis Hamilton were both behind the wheel, pushing the car to its absolute limits while generating telemetry and feedback that could reshape Ferrari's 2026 strategy. And the fallout: rival teams are scrambling to decode the advantage, questioning whether Ferrari's bold gamble will give them a decisive edge or backfire under pressure. Subscribe now, because this explosive revelation could change the entire Formula One hierarchy, and you do not want to miss a single second. The Abu Dhabi post-season testing session turned heads when Ferrari revealed it had secretly tested a critical 2026 component. The mule car featured a completely new double pushrod suspension and advanced active aerodynamic elements, hinting at a bold strategy to gain an early advantage in next season's development war. The secrecy of the test left rival teams scrambling, unsure of what Ferrari's intentions were and how it could reshape the competitive landscape. Telemetry from the mule car provided a wealth of technical insight. Engineers meticulously recorded data on suspension travel, ride height, aerodynamic load, and tire contact. Every millisecond was captured to analyze how the new components affected vehicle dynamics under high-speed conditions. This data allowed Ferrari to evaluate the performance gains in both cornering stability and straight-line speed, giving them an early understanding of how their 2026 car could behave on race weekends. The involvement of drivers Charles Leclerc and Lewis Hamilton was crucial. Both drivers pushed the mule car to its limits, simulating extreme braking, acceleration, and cornering scenarios. Their feedback on steering responsiveness, vehicle balance, and overall handling provided engineers with an essential human perspective to complement telemetry. This combination ensured that the component improvements were both measurable and practically effective. High-speed video cameras captured every detail of the mule car in action. Frame-by-frame analysis confirmed telemetry findings and revealed the dynamic interaction between suspension and aerodynamics. Engineers could see how the active front wing maintained optimal airflow and downforce, and how the double pushrod suspension absorbed curb impacts while keeping the tires planted. This visual verification was vital to ensure that performance gains were real and replicable. Mechanical simulations were also used to complement the physical testing. By feeding telemetry and video data into computational models, Ferrari engineers were able to predict how the components would perform across different tracks, temperatures, and conditions. These simulations helped optimize design parameters, providing insights that would be difficult to gather solely from real-world testing. The broader paddock reacted immediately to rumors of Ferrari's secret testing. Rival teams, media, and analysts dissected leaked images and data, speculating on the potential competitive advantage. Questions arose about whether Ferrari's audacious move would force rivals to accelerate their own development programs, or if regulatory oversight might limit the practical implementation of the new components in 2026. Finally, the Abu Dhabi test underscored Ferrari's approach to innovation: aggressive, data-driven, and ahead of the curve. By combining telemetry, driver feedback, video analysis, and simulations, Ferrari gained a comprehensive understanding of the new component's performance. This multifaceted approach positions them to enter the 2026 season with a potentially decisive edge, demonstrating that secrecy and technical audacity are now essential weapons in the Formula One development war. Ferrari's secret Abu Dhabi testing program for the 2026 mule car generated an extensive set of real-world data. Every sensor on the car captured telemetry related to suspension travel, ride height, tire load, and aerodynamic forces. This allowed engineers to understand how the new double pushrod suspension and advanced active aerodynamics interacted under actual race-like conditions. The data provided critical insights into both stability and performance, giving Ferrari an early advantage over rivals still in pre-season development. Mechanical simulations were conducted to complement the on-track findings. By inputting telemetry data into virtual models, engineers could analyze structural stresses, suspension geometry, and airflow over the car. The simulations predicted how components would behave at different speeds, cornering angles, and track conditions. This allowed Ferrari to optimize the new parts before finalizing the design for homologation in 2026, ensuring both reliability and performance. High-speed video from multiple angles added a crucial visual confirmation of telemetry and simulation data. Engineers could see the suspension respond to curb impacts, maintaining optimal tire contact, while the active front wing adapted dynamically to maximize downforce. Frame-by-frame analysis validated that theoretical performance gains translated into measurable real-world improvements, ensuring the reliability of Ferrari's early data collection. Driver feedback was another essential layer of data. Charles Leclerc and Lewis Hamilton provided real-time insights on steering feel, balance, and responsiveness of the mule car. Their input allowed engineers to correlate subjective driver perceptions with objective telemetry, enabling precise adjustments to suspension stiffness, damping, and aerodynamic settings. This combination of human feedback and technical data created a comprehensive understanding of the new component's performance. Environmental conditions were meticulously logged during testing. Track temperature, humidity, and wind speed were all recorded to evaluate their effects on the new components. This allowed Ferrari to simulate realistic race conditions and predict how the 2026 parts would behave across various circuits and weather scenarios. These insights were critical in ensuring that the car's advantages were robust and repeatable. The integration of telemetry, mechanical simulations, video analysis, and driver feedback produced a holistic dataset. Engineers could assess lap time improvements, cornering stability, and aerodynamic efficiency, enabling rapid iteration and refinement. This multi-layered approach ensured that the new components were both high-performing and reliable, providing Ferrari with a strategic edge well before the 2026 season commenced. Finally, the Paddock's reaction to Ferrari's secret testing was immediate and intense. Rival teams analyzed leaked images, telemetry hints, and insider reports, attempting to decode the potential advantage. Analysts debated whether this early innovation would translate into a decisive edge in 2026 or face limitations under regulatory scrutiny. Ferrari's audacious testing highlighted the growing importance of secrecy, data-driven development, and strategic foresight in modern Formula One. In modern Formula One, the development of a single component can have a dramatic impact on lap times and overall car performance. Ferrari's secret 2026 test in Abu Dhabi focused on a revolutionary double pushrod suspension and advanced active aerodynamics, allowing engineers to gather highly detailed telemetry and mechanical data. Every sensor on the mule car recorded precise measurements of ride height, suspension travel, tire load, and aerodynamic forces, giving Ferrari an unprecedented understanding of how these parts would perform in real-world racing conditions. Telemetry analysis revealed that the new suspension configuration significantly improved weight distribution and tire contact during high-speed cornering. Engineers could quantify the exact gains in stability and cornering efficiency, showing how the system reduced understeer and optimized traction. These data points highlighted measurable advantages in handling, providing Ferrari with both predictive insights and actionable adjustments for the 2026 car. Mechanical simulations complemented the on-track findings, allowing engineers to explore scenarios beyond what could be safely tested in Abu Dhabi. By modeling tire loads, suspension kinematics, and airflow over aerodynamic surfaces, Ferrari was able to predict how minor adjustments to wing angles and suspension geometry could influence downforce and drag. These simulations ensured that the theoretical performance gains were realistic and could be integrated into the 2026 car design. High-speed video analysis added visual verification to the telemetry and simulation data. Frame-by-frame scrutiny demonstrated how the suspension absorbed curb impacts while maintaining optimal tire contact and consistent aerodynamic flow. Engineers could observe how the active front wing adjusted dynamically in response to speed and cornering, confirming that the mechanical and aerodynamic systems worked in harmony to enhance overall performance. Driver feedback played a crucial role in refining the technical setup. Both Charles Leclerc and Lewis Hamilton provided real-time observations on steering feel, car balance, and cornering behavior. This subjective data, when correlated with telemetry and video analysis, allowed Ferrari to fine-tune the suspension damping, wing angles, and chassis dynamics. Combining human insight with raw data created a complete picture of the mule car's capabilities and potential advantages. Environmental monitoring during the test was also critical. Track temperature, wind speed, and humidity were recorded to determine how the new components would perform under varying conditions. This allowed Ferrari to anticipate potential challenges across the 2026 calendar and adjust simulations and setups accordingly. Ensuring that the car's advantages were robust under multiple environmental conditions was essential for achieving consistent competitive performance. Finally, the implications of Ferrari's secret testing program are significant. By integrating telemetry, simulations, video analysis, and driver feedback, Ferrari gained a holistic understanding of how their new components enhance performance. This multi-layered approach positioned them to enter the 2026 season with a potential competitive edge, demonstrating the importance of technical innovation, strategic secrecy, and comprehensive data analysis in modern Formula One.